Hello everyone, and welcome to this presentation on heat transfer by radiation. Today we'll be working through an example problem to understand how to calculate radiant heat loss between surfaces, specifically focusing on a common scenario in building heating. Here's a problem we'll be solving. An electric heating system is installed in the ceiling of a room. The room dimensions are 5 meters in length, 5 meters in width, and 2.5 meters in height. The ceiling temperature is 315 K, and under equilibrium conditions, the walls are at 285 K. We are told that the floor is non-sensitive to radiations. The emissivities of the ceiling and the wall are given as 0.75 and 0.65 respectively. Our task is to calculate the radiant heat loss from the ceiling to the walls. Let's begin by outlining our solution. We'll start by listing the given parameters. We have the emissivities for the ceiling, epsilon 1, epsilon 2. The room dimensions are x is 5 meters, y is 5 meters, and z is 2.5 meters. The temperature of the ceiling, T1, is 315 Kelvin, and the temperature of the wall is P2 is 295 Kelvin. Our objective is to determine the radiant heat loss from the ceiling to the walls. Now, the rate of radiant heat exchange between two surfaces in this scale, the ceiling, will denote a surface suffix 1 and the single wall denoted as suffix 2, is given by the equation that is displayed on the screen. Now, this equation can be expanded to account for the emissivities and view factors between the surfaces, and the full expression is now as shown. The term view factor 1 to 2 is known as the gray body shape factor, which incorporates the emissivities of the surfaces and the geometric view factor between them. It is as displayed in the screen. Now, to proceed, we need to calculate the surface areas involved. The area of the ceiling, A1, is given as 25 square meters. The area of the single wall, A2, is equal to 12.5 square meters. And now we need to determine the geometric view factor, F1 to 2. And that is between the ceiling and the single wall. The ceiling and the walls are perpendicular surfaces with a common edge. So to find the view factor, we calculate the ratios z over x and y over x. Now the corresponding parameters to this from standard chart and tables for perpendicular surfaces with common shape factors is found to be 0.15. Now with all the necessary values, we can substitute them into our radiant heat exchange equation, and we plug in all of the values from the Stefan-Boltzmann constants, the temperatures, emissivities, and the calculated shape factors. After performing the calculations, the radiant heat loss from the ceiling to the single wall, Q12, is approximately 398.77 watts. Now, since there are 4 walls, the total radiant heat loss from the ceiling to all the 4 walls is simply 4 times the heat loss for single wall. So 4 times 398.77, which gives us a total radiant heat loss of 1595 watts. And that is our answer. Thanks for watching. If you found this video helpful, please consider subscribing to our channel for more content like this. Don't forget to hit the notification bell so you don't miss out on our latest uploads.